This is note 6, page 2. We're going to sum up some things on how to work with expressions with negative exponents that we saw on the previous page that will make your life easier. First, for expressions that do not initially have any fractions, don't create fractions. First, you're going to simplify using the exponential rules. That will not create fractions. Then you'll remove any remaining negative exponents, if there are any. And at that point, you'll create a fraction. But basically, don't create a fraction until you have to. Now, for expressions that start with a fraction, well, you can't avoid creating a fraction. You already got one. It can be easier to remove the negative exponents first, because then your fractions all have all positive exponents. They're just easier to deal with. You could simplify by using the exponential rules, keeping the negative exponents and then removing the negative exponents. So I haven't done a problem in sort of that order, but what we're really saying here is when you're simplifying with negative exponents, there's two things you have to do. You actually have to simplify the expression using exponential rules, order of operations, and you have to remove negative exponents. The question is, what order do you do these things in? So I'm saying, if you don't have a fraction, definitely use the exponential rules first, then flip. If your problem begins with a fraction, most of you will be happier removing the negative exponents than simplifying, but you can always simplify with the exponential rules, then remove the negative exponents if you like. I'll try showing you both ways on some problem here. So, and here's a caution. This is huge. I get students rush and they make careless mistakes with this all the time. Numerical bases that have a negative exponents. Until you get really good at this, don't do this in your head. To the negative third, the most common mistake is people will just, oh, that's negative 8. No, it's not. 2 to the negative third is the reciprocal of 2 to the third. It's 1/8. So be careful. This is where you're most likely to make careless mistakes. So let's try this problem. All right, simplify. How many terms? Well, it's all one term, which means when I flip, I'll be flipping within that same one term. Are there any fractions? Nope, not yet. Well, don't create fractions by starting to flip right away. Let's just use the exponential rules, order of operations, commutative properties, associative properties, all of those are at play. It's all multiplication, which means I can ignore these parentheses and I can reorder. So if you can do this part in your head, feel free to, but I'm going to group the coefficients together. I'm going to group the x's together, and I'm going to group the y's together. So if you could do that, basically if you can go from this step to this step, great. Be careful here with the coefficients. Only the 4 is raised to the negative second. Do not do this in your head. Deal with the 4 to the negative second when you start flipping the variables as well. So I'm going to leave this as negative 3 times 4 to the negative second. Here, I'm multiplying the same bases for the x's, multiplying the same base, add the exponents, that's x to the 5th. Here, I'm multiplying the same bases for the y's, multiplying the same base, add the exponents, that's y to the negative 1st. Now, I'll deal with the negative exponents. Careful, negative 3, that's not a negative exponent, that's the opposite of 3. And by the way, notice what I'm doing. I'm drawing my fraction bar so I can lay things out where they belong. The negative 3 stays in the numerator. Now that is the reciprocal of 4 squared, so that's going down to the bottom. The x to the 5th, that's a positive exponent. I do not take the reciprocal. the y to the first, that is the reciprocal of y, actually y to the negative first, take the reciprocal of y, that goes to the denominator of the same term it's in, okay? Just one last thing to do, negative 3x to the fifth over 16y, you're done. Okay. Now, the reason this problem is already done is because I've done these notes in class and we would always run out of time, so I just filled this one in. But we can go over this quickly. This is all one term. There are no fractions. I am not flipping anything yet. I am going to say, hey, look, those are factors. I can raise each factor individually to the negative second. I am not going to do 5 to the negative second in my head. That is not negative 25. That's not what it is. When I distribute the negative 2 to the x to the negative third, that is power to a power, so I multiply exponents. Watch your sign. Negative times the negative is positive. And then the y's, that's also power to a power, so I multiply. Then I have simplified, but I need to remove negative exponents. So the 5 squared goes down, the y to the 8th goes down, the x to the 6th stays up, and then 5 squared is 25. Notice how 5 to the negative second was not negative 25. When you look at this, what was 5 to the negative second? Do you see the 1 in the answer? 5 to the negative second is 1 over 25. It's the reciprocal of 5 squared, not the opposite of 5 squared. The reciprocal of 5 squared. And over here, this is the not the way to do it. You can get the right answer, but it takes a lot longer. If you flip first, you have to flip the whole fraction because that negative, and then you have to flip the x because that negative. You've got a compound fraction, and that's just painful. So we'll go on to notes 3 next.